A model that scores 99% on its benchmark and falls apart on your actual question isn't broken. It learned the wrong thing. Here's what most explainers miss about overfitting. The problem isn't that the model is bad. The problem is that it's too good at the wrong task. It learned to recognize the specific examples it was trained on instead of learning the underlying pattern those examples represent. Think of it like a student who memorizes every answer in the textbook but can't solve a problem worded differently. They aced the practice test. They understood nothing. So how do engineers catch this? They hide part of the data. You split your data set, training data the model learns from, and test data it never sees during training. If the model performs brilliantly on training data but poorly on test data, you've caught it memorizing. That gap between training performance and test performance is the clearest signal that your model isn't generalizing. This connects to something called the bias-variance trade-off, and it's worth understanding in plain terms. A model that's too simple, say fitting a straight line through curved data, misses the real signal. That's high bias. A model that's too complex, one that bends to pass through every single data point, noise included, captures patterns that don't actually exist. That's high variance. The goal is the middle ground, complex enough to capture real structure, simple enough to ignore the noise. Engineers have concrete techniques for pushing models toward that middle ground. Regularization adds a penalty for complexity. It tells the model, you can fit the data, but the simpler your explanation, the better. Dropout goes further. During training, it randomly disables parts of the network, forcing the model to learn redundant pathways. You're intentionally handicapping it, so it can't rely on any single memorized shortcut. It's counterintuitive. Making the model worse during training makes it better at everything it hasn't seen. This matters beyond the lab. When a medical imaging model trained on data from one hospital fails at another, that's overfitting to institutional quirks, lighting, equipment, patient demographics. When a hiring algorithm scores perfectly on historical decisions but encodes the biases in those decisions, that's the same failure. The model learned the data, not the world. Every time you hear a headline about AI performing at expert level on a benchmark, ask one question. How does it do on data it's never seen? That's the only number that matters. If that was useful, subscribe New Explainer every week. I'm Ariella.